Greetings. Today we are going to talk about progressions, and we're going to explore these three: arithmetic, geometric, and harmonic. And for each of these progressions, we're going to discuss about the nth term and sum of terms. As for the sum of terms, we won't discuss about it for harmonic. And as for each of those progressions, quadratic and cubic ones won't be discussed, since for arithmetic we focus on the linear types only. Let's look at arithmetic progression. And arithmetic progression is a sequence of numbers such that difference between each consecutive term is constant. You can see what on the right what N, A, and D symbols are. So basically, n term is very simple, and you can prove this by using the very sequence itself. As for the sum of terms, it's very interesting that the famous mathematician by the name of Gauss have made this method back when he was 10, and he gave us this formula, and this formula is the one that we still use today. Now let's look at geometric. Okay, so for geometric, this progression occurs when one term is multiplied by another term, and then if you take two consecutive terms next to each other, divide together, then you get the common ratio. And if you want to look at the proof for sum of terms, you can see that as for sum of terms, you get two formulas. The one on the left is where R is with the modulus R more than 1, means to say that this formula can be used if the R is less than -1 or more than 1. Whereas for the one on the right, the Sn can be used if the R is in between -1 and 1. And if you use that formula, you can use it to derive the sum to infinity formula. How to prove it is you look at the proof that's given. You need to make sure that R is in between -1 and 1, so that the R to the power of n will tend towards 0, so it's like to converge. Thus you get the simple formula for sum to infinity. Let's look to harmonic progression. So harmonic progression is a progression where it's like arithmetic progression, but this time focusing on reciprocal numbers. So if you look at the example given, which is e.g., you can see the first term is 1, next term is half, then third, and then fourth. And the formula for the n term is given at the top, but the numerator is just 1, whereas the one at the bottom it is arithmetic progression. And as for the numerator, you can have like any constant, whatever you want. And if you want to incorporate a formula, it will not affect in any way. And as for the sum of terms, we are not going to cover this, mainly because the sum of terms is more complex and it requires the use of integrals. Let's look at the special case where you want to find the sum from term to term. If you want to find the n term, first list out the sum for Sn and the sum for Sn minus 1. Take Sn minus Sn minus 1 and you get the n term as shown in the picture. If you want to find the sum from third to seventh term, first all you need to do is to list out S7 and S2. This will give you like a block consisting of a chain of expressions, and you can immediately guess that S7 minus S2 is the sum from third term to seventh term. And there's a common mistake among many students is that if you take S7 minus S3 instead of S7 minus S2, T3 will be unaccounted for when you want to get the sum. So to avoid this kind of mistake, rather than subtracting immediately, just list it out first. This will help you to see whether any term is missed out when you want to subtract later. And that's it for my video on progressions. Later we'll explore about series. Thank you.